When considering their data center transformation, many organizations look to cloud computing as a possible solution and enabler of change. In this session, we'll attempt to define cloud computing and describe a common approach for cloud adoption. A good definition of cloud computing comes from the US National Institute of Standards and Technology. They define a cloud as having 5 essential characteristics. On-demand self-service, such that the resource is available at the touch of a button for those who should have the rights to request it. Resource pooling, implying that the resource provided is coming from some kind of shared pool. Rapid elasticity, implying that the resource provision can both grow and shrink depending on the demand from the consumer. A measured service, such that we are at least aware of how much resource is being consumed and possibly as the basis for metrics or chargeback. And finally, broad network access. In other words, the resources available from an easily consumable interface, such as a web browser. According to NIST, 3 service models are available. Infrastructure as a service, servers and storage available with all of those characteristics. Platform as a service, a technology platform to allow those applications or services to run against. Or software as a service, applications or services to support business processes, again with all of those characteristics. Finally, 4 deployment models are available. Public cloud, where the resource consumed is outside of the data center and is part of a resource pool shared between any number of organizations. Private cloud, where the resource consumed is entirely within the data center and is dedicated to a single organization. Community cloud, where a finite number of organizations share a dedicated resource. And hybrid cloud, where the resource is made up of both public and private components. So if that is the definition of cloud, how might it be adopted? The first key message is that it's likely that in nearly every organization a combination of all of these service models and deployment models may be appropriate. Most organizations find themselves today with most applications deployed in a dedicated silo of computing resource. Some applications may have sufficient constraints such that they are likely to need to stay siloed in the long term, but the majority are likely to benefit from some kind of cloud model. The simplest adoption will be to private cloud, and for most organizations we talk to, we expect that the majority of their estate will be best served by a private cloud. However, in nearly every organization, a subset of what they deploy may well be deployable to the public cloud. If an organization is sufficiently efficient at their private cloud, however, over time they may well want to run what is publicly deployed privately again, simply because it is more efficient. As long as standards are adhered to, this should be perfectly possible. If this is the high-level steps, what is the typical adoption strategy going to look like over time? As already mentioned, many deployments are currently siloed, but we already see many trying to move to a more shared environment via pools of resources. In some ways, the adoption of cloud is simply to add on to this deployment self-service and measurement capabilities. But at the same time, we have seen the emergence of various internet-based offerings which have evolved into public cloud offerings. The trick for IT then is to adopt the best of both worlds by embracing and governing publicly available cloud capability and harnessing it to supplement private deployment. A key thing to remember about cloud is that just as we do today, we will need various levels of service and to deploy the most appropriate service for the most appropriate cost. An example of how this might be done is that the cloud may be made up of a number of subclouds based on SLA, for example bronze, silver, gold and platinum. As we go up through the offering, the resilience, availability, scalability and performance of the resource will all increase. However, as we travel down, cost will decrease. It will be up to the consumer to choose the appropriate level based on value. So cloud computing techniques and technologies offer us a mechanism to transform the data center. In the next session, we'll consider the architectural implications of this approach.